Hi everyone, welcome back to Fat Cat Maths. Today we're going to be looking at surds. Surds are really complicated and I would certainly say that they're one of the hardest components of GCSE maths. If we start right from the beginning and work our way up to GCSE style questions, I promise that you will understand them more at the end of this video. Surds are simply a number left in square root form. These two numbers in front of you are the exact same number, but the one on the left is a lot easier to understand, especially if it's in the middle of a fraction or an equation. What's good about complicated topics in GCSE maths is that there are only a finite number of questions that they can then ask you. For surds, you will likely get one of the following: to simplify a surd, to add, subtract, multiply or divide some surds, to expand a set of brackets, or to rationalise. We'll go on to what that means a bit later. The first thing we need to do is really get to grips with the rules of surds. If you multiply two of the same surds together, the answer will always be the number without a square root sign. So root 5 times root 5 will just be the number without a root sign, so 5. If you multiply two different surds together, you can put the numbers under one roof. So root 5 times root 7, we would put that 5 times 7 under one roof and solve it as normal. So it would be root 35. This works the other way around too, so I can split a larger number into its two factors. So root 15 could be split into a root 3 times 5, and then further split into a root 3 times root 5. If you divide two different surds, you can also put those under the same roof. So root 22 divided by root 2, we put these under the same roof and solve as normal. So the answer would be root 11. You can add or subtract multiples of the same surd, just like you can with multiples of x or multiples of y. 3 root 3, add 4 root 3, would be 7 lots of root 3. 10 root 6, take away 3 root 6, would also be 7 but root 6. So let's start with simplifying a surd. If we were given root 18 and asked to simplify it, the simplified version would be 3 root 2. If you're like me and a lot of other students, this seems a bit counterintuitive because the number on the left looks a lot more simple. What they mean by simplify a surd is to make sure that the number underneath the roof does not have any square number factors. 18 has 3 sets of factors. 1 and 18, 2 and 9, and 3 and 6. If we remind ourselves what the square numbers are, we can see that 18 does have a factor that is a square number. If that's the case, then it is not as simplified as it could be. We're going to split that 18 into its two factors, 2 and 9. That can further be split into a root 2 times a root 9. Root 9 is no longer technically a surd because we can solve it. Once solved, we get 3, and root 2 stays the same. So we would have 3 lots of root 2. Pause the video here for these 3 questions and see if you can simplify them. Root 50 has a square factor. It can be split into 25 and 2. The square root of 25 can be solved to make 5, so the answer would be 5 root 2. Root 27 can be split into root 9 and root 3. Root 9 can be solved to 3, and then we leave the root 3 the same. So the simplified version of root 27 would be 3 root 3. Root 100 is a nice easy one because we can just solve it straight away. The square root of 100 is 10. Next, let's look at simple sums involving surds, and we will start with multiplication while it's fresh in our memory from simplifying. We can multiply surds by putting them under the same roof. So root 5 times root 4 would be root 5 times 4, which is root 20. If there's a larger number in front, we first times those numbers together. So 3 times 4, that gives us 12. And then we solve the surds as normal. So root 3 times 2. That will give us an answer of 12 root 6. With division, again we put these under the same roof, so root 14 divided by root 2 will be root 7. Just like multiplication, if you had a larger number in front, you would do the larger division and then work out the surds as normal. With adding and subtracting, if we have the same number underneath the root, then we can group them together. So 3 root 3 add 4 root 3 would just be 7 lots of root 3. If there's a different number under the square root sign, it's a little bit more complicated. As it stands, we can't add this 3 root 8 and 5 root 2 together. But if we can convert that root 8 into a root 2, then we can add them together. This doesn't work with all surds, but in this case it does work, because root 8 can be split into its factors of 4 and 2. 4 can then be solved because it's no longer really a surd. We can make that into a full number, which is 2, and times it by the 3 at the beginning of the surd. So now it will be 3 times 2 times a root 2. This now makes 6 root 2, add 5 root 2. Now that the same number is underneath the roof, we can add them together and make it 11 root 2. The same applies with taking away. If we have the same number under the square root sign, then we can just take away as normal. 9 root 3 take away 2 root 3 would equal 7 root 3. 5 root 18 minus 3 root 2. As it stands, again, we can't directly do that, but if we transform that root 18 into a something root 2, then we can. Root 18 can be split into its factors of 2 and 9. Square root of 9 is 3. So if we times the 3 by the 5, that gives us 15, with a root 2 left over. So now our new question is 15 root 2 take away 3 root 2. And the answer to that is 12 root 2. Let's have a look at the third type of question you could be asked, and that is how to expand a set of brackets. So just like with algebra, we need to times the first part of the first bracket by everything in the second bracket, and then the second part of the first bracket by everything in the second bracket. So we would do 6 times 6, which is 36, and then 6 times a minus root 8, which is minus 6 root 8. Then we would times the minus root 8 by a 6 to give us minus 6 root 8, and then a minus root 8 times a minus root 8, which would be a positive because minus times minus is positive, and just an 8 because a root 8 times a root 8 would be the number without the root. We can then simplify this by taking our full numbers down, so 36 and a positive 8 makes positive 44. And then because there is the same number under that square root, we can group them together. So a minus 6 root 8 minus 6 root 8 would be minus 12 root 8. Now sometimes in these types of questions, they will tell you that they want it in a specific format. So in a question, they might say that they want the answer in the form k minus 8 root 2. Currently, we have it in the form of 44 minus 12 root 8. That means that we're going to have to split that root 8 into a root 2 and a 4. So if we now make it 12 root 4 times 2, We can solve the root 4 because that's no longer a surd. That will be a positive 2. Times that by the 12 to make minus 24. And then the root 2 is left over. So overall we have 44 take away 24 root 2, and that's in the right format. Next, let's look at rationalising a surd. To rationalise a surd, you will always be given a fraction. Rationalising essentially means that you need to get rid of any surds from the bottom of the fraction. In order to do that, we will be utilising the rule that we learnt very early on in the video, where a root times a root is the number without that root. So to get rid of that surd on the bottom, we're going to times the bottom by itself. But just like in any fraction, we have to do to the top whatever we do to the bottom. Now we have 4 root 3 over 3. And that's our fraction rationalised. Often questions will be a little bit harder than this though, and you will have something more than just a single surd on the bottom. Here we have 4 over 5 root 3. We have to do a very similar thing here, in that we times the bottom by itself. But this part is really important. If there are multiple parts to your denominator, like a 5 plus a root 3, or a root 2 minus 1, you need to change the sign when you times it. This is the only way that we can get rid of the surd on the bottom instead of making it longer. So instead of multiplying the bottom and the top by 5 plus a root 3, we're going to multiply the bottom and the top by 5 minus root 3. So now on the bottom we have a set of brackets, just like in the previous type of question. 5 times 5 will be 25. 5 times minus root 3 will be minus 5 root 3. Root 3 times 5 will be positive 5 root 3. And a root 3 times a minus root 3 will be minus 3. That minus 5 root 3 and positive 5 root 3 can now cancel themselves out, leaving us with just the numbers 25 and minus 3. On the top, if we times that 4 by what's inside the brackets, we get 20 minus 4 root 3. And on the bottom, we have 25 minus 3, which is 22. Brilliant. So before we finish, let's just revisit the rules of surds. If, like me, you find flashcards really helpful, I'd really recommend just pausing it here and taking note of what you can see. Surds do take a while to get the hang of, but I promise that once you've practiced using them, these will come very naturally. There's quite a lot to this topic, so completely understandable if you need to rewatch it a few times, and I would really recommend the exam walkthrough. Thank you again for taking the time to listen, and I really hope it helped. It would really mean a lot to me if you could hit that subscribe button, because it'll let me know that these videos are helpful, and it'll mean that I can continue to make new content every single week. I'll be covering all of the different topics from all of the UK exam boards, so this channel will serve as a great addition or even an alternative to revision guides. Good luck with the rest of your revision, and I will see you next week.